Good morning. I am Devasena. In this lecture, we are going to discuss about TCP Ip Protocol Stack. This topic is present in the subject Wireless Networks. Transmission Control Protocol TCP. TCP is a connection-oriented protocol, which means a connection is established and maintained until the application's programs at each end have finished exchanging messages. It determines how to break application data into packets that networks can deliver. Sends packets to and accept packets from the network layer, manages flow control, and because it is meant to provide error-free data transmission, handles retransmission of dropped or garbled packets as well as acknowledgement of all packets that arrive. In the Open Systems Interconnection, that is OSI communication model, TCP covers parts of layer 4, the transport layer, and parts of layer 5, the session layer. OSI reference model versus TCP IP conceptual layers diagram. This is a representation of OSI reference model as well as TCP IP conceptual layers. The physical layer and data link layer that is present in the OSI reference model is connected to the network interface layer in TCP IP conceptual layers. Similarly, network layer in OSI reference model is analogous to network layer in TCP IP. The transport layer in OSI reference model is analogous to the transport layer in TCP IP, and the session layer, presentation layer, application layer in the OSI reference model is analogous to the applications layer in TCP IP. This is represented in this diagram. See the TCP IP protocol stack diagram. This is the TCP IP protocol stack. Here we are having 4 layers, that is application layer, transport layer, network layer, link layer. In further slides we are going to discuss this in detail. Now we discuss about application layer in TCP IP protocol stack. This is the representation of the application layer. Now we are going to discuss the details. Application layer sends and receives data for particular applications such as domain name systems, that is DNS, Hypertext Transfer Protocol HTTP, and Simple Mail Transfer Protocol SMTP. Now we see the transport layer. This is the transport layer. Transport layer provides connection-oriented or connectionless services for transporting application layer services between networks and can optionally ensure communications reliability. Transmission Control Protocol TCP and User Datagram Protocol UDP are commonly used transport layer protocols. Now we see network layer. This is the network layer. Network layer routes packets across networks. Internet Protocol version 4, that is IPv4, is the fundamental network layer protocol for TCP IP. Other commonly used protocols at the network layer are IPv6, ICMP, and Internet Group Management Protocol, that is IGMP. Hardware layer. This is the representation of a hardware layer. Hardware layer, also known as the data link layer. This layer handles communications on the physical network components. The best known data link layer protocol is the Ethernet Selective Repeat Protocol (SRP). TCP uses Selective Repeat Protocol (SRP) with positive acknowledgements and timeout. Each byte sent is numbered and must be acknowledged. A number of bytes can be sent in the same packet, and the acknowledgement, that is ACK, indicates the sequence number of the next byte expected by the receiver. ACK carries sequence number M, which provides acknowledgement for all packets up to and including packets with sequence number M-1. If a packet is lost, the receiver sends duplicate ACK for a subsequent correctly received packets. We see the facilities provided by Transmission Control Protocol TCP. Stream data transfer, reliability, flow control, multiplexing, logical connections, and full duplex. These are the facilities that is being provided by TCP. Now we see the stream data transfer facility. From the application's viewpoint, TCP transfers a contiguous stream of bytes. TCP does this by grouping the bytes in TCP segments which are passed to IP for transmission to the destination. TCP itself decides how to segment the data, and it may forward the data at its own convenience. We see the reliability facilities. TCP assigns a sequence number to each byte transmitted and expects a positive acknowledgement from receiving TCP. If the ACK is not received within a timeout interval, the data is retransmitted. The receiving TCP uses the sequence numbers to rearrange the segments when they arrive out of order and to eliminate duplicate segments. We see the flow control facilities. The receiving TCP, when sending an ACK back to the sender, also indicates to the sender the number of bytes it can receive beyond the last received TCP segment, without causing overrun and overflow in its internal buffers. This is sent in the form of the highest sequence number it can receive without problems. We see multiplexing facilities. To allow for many processes within a single host to use TCP communication facilities simultaneously, the TCP header provides a set of addresses supports within each host, concatenated with the network and host addresses from the Internet communication layer. This forms a socket. A pair of sockets uniquely identifies each connection. We see the logical connections facilities. The reliability and flow control mechanisms described above require that TCP initializes and maintains certain status information for each data stream. The combination of this status, including sockets, sequence numbers, and window sizes, is called logical connection. Each connection is uniquely identified by the pair of sockets used by the sending and receiving processes. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video, means you can share this video to your friends.